Hello everyone. Today we're going to be going over Integrated Math 3, the exponentials, the laws of exponents. This is practice 1. The front side we did in class together. All I wanted everybody to do with this top part is to recognize the difference between base, exponents, and coefficient. Okay. For example, in this one, 7 is what's known as the base. It is the big number or big variable that the exponent is attached to. And 2 would be the exponent or the power. For this one, x is the base, -3 is the power or the exponent. This one has 3 pieces to it. That 3 in the front is not a base. This power of 10 has nothing to do with this 3. This guy is known as a coefficient. It's a number in front of a variable waiting to multiply. The base is y and the exponent is 10. Sometimes it can be a little confusing when they put parentheses around two distinct terms like 2 and x. But this is really one term, 2 times x, and because it's in parentheses being raised to a power, then this whole thing together, 2x, is the base. That 2 is not a coefficient the same way this one is. This 2 is actually going to have to get raised to the power of 5, which, by the way, is the exponent. And just to make sure that we're all clear, this 9 is a coefficient. The a is the base. But what do we do if we don't see an exponent, right? We don't see an exponent like we saw here or here, here, or here. We have to understand that no written exponent is an exponent of 1. Okay? The understood exponent is 1 if it's not written. Before we got into the laws of exponents, I wanted to make sure everybody understood the difference between like terms when you're adding and subtracting. When you're multiplying and dividing polynomials, you don't need like terms. It's when you're adding or subtracting that you need them. So just a quick clarification. If 2x and 3x are adding, like this is, that just makes 5x. Notice it does not make 5x squared. These two x's do not become x squared unless you were multiplying in this situation, but we're not. If you're adding them up, you're just going to keep that variable, because they're like terms, and do it to the coefficients. 2 plus 3 is 5. Same thing is true here. 2x to the 5th plus 3x to the 5th is just 8x to the 5th. Notice it does not become 8x to the 10th because we're not multiplying, right? Exponents only add when you're multiplying. So just leave it x to the 5th. 7m to the second minus 1m to the second is 6m to the second. 4a minus 2b can't be done because these guys are not like terms. They have different variables, so that's as simple as that can get. The same is also true for this last example. 10y to the 7th minus 10y to the 3rd. They look similar. They have the same coefficient. They got the same base, but in order to be like terms, to add or subtract them, they also have to have the same exponent, and these guys don't. This one has a 7, this one has a 3, so you can't actually subtract them. So you just have to leave that the way it is. There are 5 laws of exponents when it comes to multiplying and dividing that I want to make sure we cover, that we're fairly clear on, and we're going to do some examples on the back. One is, as long as you have the same base, if you're ever in a situation where you have to multiply, you are going to add exponents. So if x to the 3rd were to multiply x to the 7th, you would add these and it would become x to the 10th. Second law has to do with when you're dividing. When you divide, you want to subtract exponents. So say I had b to the 10th power being divided by b to the 8th power. In this situation I would subtract. You always subtract top to bottom. You end up with b to the 2nd power here. Number 3, if you raise a power to another power, like this situation. Say you have x to the 4th, and then I'm going to put parentheses around it and raise it to yet another power, let's say the 6th. If you raise a power to another power, you are going to multiply the exponents. 4 times 6 would be 24, so this becomes x to the 24th power. Law 4, anything to the power of 0 is 1. Just the number 1, right? So x to the power of 0 is not just like x or x1 or whatever, it's just the number 1. Anything to the power of 0 makes 1. And the fifth one, negative exponents go to the bottom of a fraction and turn positive. So say I had something like x to the negative 9th power. I would have to create a fraction, move this to the bottom of the fraction, and turn that negative 9 into a positive 9. What goes at the top of the fraction is whatever the coefficient is here. If I didn't write anything, then that is a 1 in that situation. But if I had something like 2y to the negative 3rd, and I made that fraction, the y to the negative 3rd goes to the bottom to become y to the positive 3rd, and this time the coefficient is a 2, so at the top of this fraction would be a 2, so forth. So let's see several of these examples with coefficients and other things that kind of confuse students from time to time. Flip over to the back. We got 16 of these we're going to roll through. Number 1 is x to the 6th times x to the 3rd. That's law 1. You would add the exponents and get x to the 9th. Y to the 12th being divided by y to the 7th. If you're dividing, you subtract the exponents, so you would end up with y to the 5th. If you raise a power to another power, m to the 2nd to the 7th, these guys multiply. 2 times 7 would make 14, so you get m to the 14th power. B to the power of 0. Anything to the power of 0 is just 1, the number 1. Negative exponents, like a to the negative 5th, have to go to the bottom and turn positive. So there's a fraction, a to the 5th at the bottom. What goes at the top is whatever's in front. If you don't see anything in front, that means it's 1. 1 over a to the 5th. Remember that numbers can also be the base. The base doesn't always have to be a letter. In this case, the base is 7 for both of these. They are multiplying. Since we're multiplying, we have to add their exponents. 2 and 7 would make 9. You end up with 7 to the 9th power. Number 7, we are raising a power to another power. X is to the 4th and then to the 3rd, and 4 times 3 makes 12. But here's the tricky part to this. That 2, right, is a coefficient for x to the 4th, and you are not going to do 2 times 3 here and get a 6. It's also not just going to stay 2. This big 2 actually has to get raised to the power of 3, which is out here. So think of it like this. That big 2 in front of x to the 4th is getting raised to the 3rd power. 2 times 2 times 2 is actually the number 8. So when you do all of this one, you end up with 8x to the 12th power. Coefficients in number 8, we're dividing. We know that exponents subtract, but the 12 and the 6 are not exponents. Those are legitimate numbers that have to divide. 12 divided by 6 is 2. The x, however, we're going to subtract their exponents and end up with x to the 3rd power. Moving back up to the top, 6a to the negative 3rd, that's a negative exponent, so it's got to go to the bottom of a fraction and turn positive. A to the positive 3rd. The coefficient 6 is what goes at the top. Here we have 3 multiplying terms. They all have the same base of y, so we know it's going to be y. Since they're all multiplying, that means their exponents are going to add. 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is 12. Number 11, here you have that power of 0 rule. But in this situation, that power of 0 is only applying to the x. It is not applying to the coefficient of 3. This 3 is waiting its turn to multiply, and when x to the power of 0 turns into 1, you end up with 3 times 1, or 3. Number 12, this says n to the 2nd over n to the 6th. This is dividing, so we have to subtract exponents, and you're always subtracting from top to bottom. 2 minus 6 is actually negative 4, so we end up with n to the negative 4 power. But remember, you can't leave negative exponents. That's not considered simplified. Negative exponents then have to go to the bottom of a fraction and turn positive, and then the coefficient goes at the top. So the final answer to this one should be 1 over n to the 4th. 13, we have 2b to the 2nd over 3b. We can try to divide 2 and 3, but that's just going to give us a decimal because this is a fraction, 2/3. So just leave it as 2/3. The b's, however, this is b to the 2nd power. At the bottom is just b, which means b to the 1st power. So you'd subtract since we're dividing, and you would end up with just a b to the 1st power, or just b, 2/3 b. 14, we're multiplying. Remember that the big numbers in front are coefficients, not exponents. So they're not going to follow the laws of exponents. They're actually going to multiply like numbers would. 4 times 2 would give us 8 in the front. These x's are the same base, and since we're multiplying, we're going to have to add their exponents. 5 and 6 make 11. 8x to the 11th. This one we've got 2 multiplying terms inside, and then we got to raise them to the second power. So I'm going to focus first on just figuring out what would I get if I multiplied those two to start with. I'm going to leave the parentheses with the power of 2, but what would I get inside? Coefficients 2 and 10 would multiply. 2 times 10 is 20. X to the second and x to the third. If you're multiplying, you're going to add their exponents. That would be x to the 5th power. Now that 20x to the 5th is now going to get raised to the second. This is law 3. If you raise a power to another power, you're going to multiply. So you're going to end up with x to the 10th. But what should the coefficient be here? It's not going to stay 20 because that 20 is in a parentheses that's being raised to the power of 2. And remember that 20 is not an exponent, so you're not going to do 20 times 2 and put 40 here. This means 20 to the second power, right? And 20 to the second power means 20 times 20, which is actually the number 400. You get 400 x to the 10th. Final one, 16, we have a 5m to the 0 out here. The m to the 0 part is going to turn into a 1, because anything to the power of 0 is 1. 5 times 1 ends up being 5. Now it's 5 times m to the negative 1, because that's a negative exponent. It's going to go to the bottom of a fraction and turn positive. And if it's a positive 1 for an exponent, you don't even have to write it. And your coefficient will be at the top. So this one ends up being 5 over m. All right? Hope that was helpful. Catch you next time.